Okay. For time series analysis, we would like to, of course, the basic, we'd like to know how to model using ARIMA. And then at the end of this few sessions that we have on time series, you should also be able to model volatility. Okay, may I know, guys, if in your previous subjects, you were able to model, use GARCH function in order to model volatility? Paki-chat nga, guys, please. We're able to model volatility. Yes or no, please? Not sure, okay. Nick, yung answer mo ba yes? O sa recording yan? For the recording, okay. So, pag walang answer, usually ibig sabihin nun, hindi kayo sigurado or hindi nyo alam, no? So, no. I take that for a no, guys. Is that an accurate assessment, Colleen? Tama ba? So hindi pa kayo nakapag-model ng volatility. Kasi if you have done so, guys, maybe we'll skip that. Otherwise, if not, then we will go through the process of modeling volatility. Kasi ARIMA as a model in modeling time series fails in as far as including the volatile nature of the usually the returns of your data. So kaya nga gumagamit pa ng an extension of ARIMA. Well, technically it's not an extension, it's a further improvement of ARIMA, which is the GARCH model. So I'll assume, guys, that you have no or very scant knowledge of GARCH. So after ARIMA, we're going to take that and some special functions on time series. And then we close the chapter on time series, and then we move on to other topics like portfolio optimization and others, because this is all about financial analytics. Now, what I'm excited about actually is more on the machine learning and the deep learning, okay? And we're going to fuse R and Python. In particular, we're going to use the Jupyter Notebook as an IDE for Python. There are several advantages of using the Jupyter Notebook for Python. In fact, you can also use Jupyter Notebook for R in lieu of RStudio. Okay, so let's have a brief review, guys, of what we have done so far. Okay, so the packages that are required is the forecast package, FPP3, quant mode. We used quant mode already before. T-series and time series, XTS. Okay, ggplot2 for data visualization. Urca, this is also for volatility. Plotly and ggfortify, this is used to empower the ggplot function for data visualization. Okay, I would that you please require the packages. By the way, guys, next time when we meet, make sure that the packages have already been installed. Okay, have already been accessed, and then also the data that we are going. I would normally tell you what data we're going to use. Okay, so in this case, we were using the air passengers data set, and this I think came from the datasets package. Let me just check. Air passengers. Okay, yeah, this is from the datasets package. Okay, the datasets package also include many other packages that come with it. One of which is the air passengers dataset. So we started looking at the air passengers dataset last time. In this, so we renamed the object. So let me just access first the data. So here I now have the air passengers, and in order for us to generate the the data set itself. And use this air passengers. Okay, the view function will allow us to access the data and see it in a screen, in a spreadsheet in RStudio. Okay, we will not do that anymore. We will go directly to converting using a different name for air passengers for brevity, AP. Okay, so let's do that. So we now have an object here, AP. Okay, it's also a time series. Okay, 144 observations all in all from 1949 up to 1960. Okay, and the class of AP. So it's a time series. Okay, it's a TS object. Okay, so yeah, I think we're finished with this last time, di ba? So sabi natin, we were counting how many missing values are there. Some, and there are no missing values, kompleto siya. Frequency nito, sabi natin, di ba, 12 siya, monthly data kasi siya. And the cycle of AP, okay, so ito yung plot niya. Cycle 1940. So lahat ng ano, all the months are yung January is 1 and then December is 12. Okay, up to 1960. Okay. Summary, guys, gives us yung six number summary, minimum, maximum, first quartile, second quartile, third quartile, and also the mean. Okay. All right, just a quick review of what we have done so far. Okay, then what we did last time was to have a better appreciation, better understanding of the data set by plotting it. So we use the plot function of base R. So we're plotting the object AP, and we're giving it a label, x-axis date, y-axis passenger numbers in thousands. The figures are in thousands. And then the main plot is air passenger numbers from 1949 to 1960. Okay, and then we generate the plot, P1, the object, Control Enter. Okay. As you can see, guys, there's a trend. Okay, there's a trend, and the trend seems to be is not necessarily linear. It seems to be increasing over time. Okay, and there's also seasonality. We mentioned that there are peaks and troughs in this data last time. So if we take a look at the mean, the average of our data set, the mean is not constant. What do I mean by the mean is not constant? Suppose we take a look at this portion of your segment of your data. The mean of this segment is somewhere here, somewhere between 100 and 200. But if we take a look at this segment, the mean is now between 400 and 500 sa segment na to. So that's indicative of non-constant, non-fixed mean. Okay, the mean varies across your data set, across time here. Okay, and also your variance is not constant. Okay, this is non-fixed variance. Okay, you can find here the peaks and the troughs. Okay, it's increasing over time. Okay, so this is these are the attributes of our data air passengers. Now our object is to model this. Our object is to come up with a model that will forecast your data for maybe the next 1 year, the next 3 months, etc. Okay, so there are several ways to forecast your data. Okay, and one of the most popular ones, most powerful ones, is the ARIMA model, the autoregressive integrated moving average, which we introduced last time. So the ARIMA model, ARIMA was developed by Box and Jenkins. Okay, ito no, si Box and Jenkins, sila yung nag-develop ng ARIMA model. But in order for us to use the Box and Jenkins approach, okay, we have to there has to be we have to have there has to be certain parameters for us to follow. Okay, so before we go there, let's first take a look at the seasonality effects. Of course, in this time series, you can already see that there's seasonality indeed. Okay, this one, in certain periods of the year, there's an increase in the air passengers, and in some portions of the year there are decreases. Okay, it really goes down. And the best way to look at this is via the box plot. So here we're creating an object called BP1 box plot 1, and we're using the graphics function of R, okay, and use the function box plot. And the code for that is the AP, okay, air passengers object, and then the cycle AP. Take note, guys, that the cycle AP, we did that a while ago. We ran that, and it turned out that the cycle is from 1 to 12 for each year, indicating that this is monthly data. Then we have the label for the x-axis, date, and the label for the y-axis, and then the mean. Okay, so let's generate this object. Okay, there. Okay, as you can see, guys, so this is your air passengers, and it's plotted via the cycle. The cycle is from 1 to 12. Okay, and we can see here that the month of July seems to register the highest passenger arrivals. Okay, and there seems to be a toss-up between January and November for the lowest arrivals. The median, we can see that the highest median is July, followed by August, and then September. Okay, September and June seems to be on the same level. Okay, tapos yung nako-congregate talaga yung low levels dito sa February, yung median niya, no? Yan. Okay, so this is a very nice way to understand your data more, yung AP data natin. Okay. Some inferences here which we looked at last time, so I won't anymore deal with this. And I just mentioned, guys, yung number 4, no? Yung there are no outliers, no missing values. Walang outliers dito, walang points outside the this is the IQR quartile 3 plus 1.5 times IQR. So that's what you learn from your basic stat, guys. And there are no points outside. So wala naman siyang outliers based on Tukey, T-U-K-E-Y. It was Tukey who developed this box plot. Because there are different ways of computing for outliers. One of which is the Tukey's. Okay, sulat ko nga yun, baka maybe ko lang dito. Okay. Tukey's box plot to, no? And according to Tukey's box plot, any data is an outlier if it falls outside the, okay, this is quartile 3 plus 1.5 times IQR. By any chance, guys, do you recall what IQR is? Anybody, guys? Do you recall what the IQR is?
Sir, interquartile range?
Yes. So how do you compute for the IQR? It's simply your quartile 3 minus your quartile 1, di ba? Okay, so just a very quick review of your stat. Okay, so this is your 1.5 times interquartile range, and any point outside this whisker, okay, is considered as an outlier, and any point outside this whiskers, guys, are also considered as outliers. So that's why it's mentioned here that there do not appear to be any outliers and there are no missing values. Okay, so no data cleaning is required since there are no outliers. Okay, so we said, guys, that when there's seasonality, seasonality can either be additive or multiplicative. When is a series? When does a series have additive seasonality? It's additive seasonality when the peaks and the troughs, when the peaks and the troughs seems to have a constant difference, okay, constant deviation. Here, the difference between the peaks and the troughs seems to be increasing over time. Okay, nag-i-increase over time siya. So this is indicative of a multiplicative seasonality. Okay, as compared with, which I mentioned before, guys, last time, a multiplicative seasonality maintains a constant difference between the peaks and the troughs. So there's a trend here, and also there's seasonality, and it appears that the seasonality is multiplicative. Okay, so we said that we can use the decompose function. Okay, so just by way of just for us to appreciate where decompose function comes from. So it's coming from the stats package. Okay, so here you have the syntax x, type whether it's additive or multiplicative. It's a simple function. Okay, let me close these air passengers. Okay, so here we're creating an object called decompose air passengers, decompose AP, additive. Okay, of course, you can name this any way you want, but it's good to name your objects that you're creating in R. That's descriptive of what your data contains. So we're using decompose. The X here, your object is AP, and our type is additive. Okay, so let's run this, and then we use the autoplot decompose additive. Let's plot this. And what the decompose plot does is to decompose your, okay, this is your data. Okay, so let me, okay, so this is our data, our original data, and it breaks down our data into three parts. Okay, first is the trend. Okay, so this is the model for the trend, and then the seasonality. Okay, and then we have this one, the remainder. The remainder is that part of your data which cannot be, which is not captured by the trend and the seasonality. Okay, so this is the irregular part of your data. Okay, then we can also use the multiplicative. Okay, here. So they use different formulas, guys. When you plot using multiplicative or additive seasonality, it will give you, okay, so almost the same lang naman, no? But there are nuances as far as the seasonality is concerned and the remainder is concerned. Medyo magkaiba yung sa remainder nila, no? Okay, kasi iba yung nakaka-capture ng multiplicative na seasonality at saka yung linear, yung additive na seasonality. Okay, so that's a quick review of what we have discussed so far. Okay, clear naman so far, guys, yung discussion natin? Clear so far?
Opo, sir. Gets po.
Okay, good. Thank you. Okay, now we mentioned something about stationary. Okay, Unfortunately, the original file of this contained certain discussions on stationarity, no? So I'm wondering why I seem to have lost that file. Kasi dito kagad, tinetest kagad yung stationarity. Okay, so when is a time series stationary? The time series is stationary, okay, when what were the qualities that we mentioned last time? Kailan ba stationary yung data natin, guys? What are the qualities of your time series in order for it to be classified as stationary?
Siya affected by time, sir.
Yeah, sorry?
I remember saying something last week about not being affected by time.
Okay, so number one, dapat yung mean niya constant, guys. Should be fixed in the mean. Okay, as I mentioned to you a while ago, ito guys, for different periods, no, magkakaiba yung mean niya. No? Ito, if you take a look at this one, if you drop a line here, guys, yung mean niya over here. Pag dito naman, tumataas yung mean. Okay? So the mere fact that it has a trend, it's indicative that the mean is not constant. So nagbabago siya over time. Also, secondly, this is not stationary because of the volatility. Take note, guys, of the changes in the variation of your data points. Okay? Ito yung peaks and troughs natin, di ba? Pag constant yung variance yan, hindi masyado nagkakalayo yung up, yung mga ups ng data at saka yung mga downs ng data. Here, guys, medyo malaki yung yung variation, ano? So this tells us that this data, this time series is not stationary. Okay? Now, why is it important for us to first determine if the data is stationary or not? Why? Because if you're going to model this using Box-Jenkins ARIMA model, we cannot use that model if the data is not stationary. Okay, that's the rule there. Box-Jenkins model, the ARIMA model, requires that your data should be stationary. Pag hindi stationary yan, wala, hindi natin magagamit yung Box-Jenkins approach, yung ARIMA model. Okay, so what to do, guys? What to do? Okay, so saan ba tayo natapos last time? Incomplete talaga yung file. No? I lost the original one. The original one, the one that I did, had 300 rows. Okay, 300 rows. Ito, na makita. So anyway, guys, sige. I'll try to look for that, guys, and and hopefully we're able to really complete this. No? Okay. So you need to convert first, guys, the data in order to make it stationary. So there are two ways, guys. Number one, the first way is to do a log transformation. So we have to transform the data, okay, in order to convert our data series into a stationary data. Now, why is it important for us to get to convert it into a stationary data series? It's because we want to make use of the ARIMA function. Okay, so oftentimes what's done is to do the log transform. This will remove the unequal variance. Okay, that will remove the unequal variance. A second method will be to difference your data. To do differencing. Differencing transformation. Okay, now what will this remove? What do you think this will remove, guys? Okay, this will remove or address the non-constant the non-constant mean, no? Or the trend. Kasi guys, di ba pag may trend yan, hindi constant yung mean yan. Okay? So in a while, we're going to look at this because we can only use ARIMA, guys, if stationary yung data natin. Okay? But just by looking at it, just by looking at our plot, okay, you already know, guys, that this is non-stationary. And obviously, we cannot use ARIMA. We cannot use Box-Jenkins model for this. We have to convert this. Okay, we cannot use AP, the object AP as is. Okay, what we have to do is to convert it into another data, transform it into another type of data so that it becomes stationary. And then if it's now stationary, then we can now apply the Box-Jenkins model for that. Okay, so how do we test, guys, if indeed the data is not stationary? Okay, we can use this. This is the this is already the augmented, or how should I say, the revised version. The initial version was the Dickey-Fuller test. So the Dickey-Fuller test allows us to see if the data is stationary or not. So we're using from the T-series package, okay, this function ADF.test. Okay, let's see first. Okay, it's always a good practice, guys, to ADF.test to understand what the function does. Okay, this one, the augmented Dickey-Fuller test. Okay, computes the augmented Dickey-Fuller test for the null that X has a unit root. Okay, ano ibig sabihin ng X has a unit root? AKA, guys, ang ibig sabihin yan, X is not stationary. Okay. Another way to call a non-stationary data is that data has a unit root. Okay, we don't want the data to have a unit root, or we don't want the data to be non-stationary. Okay, non-stationary is equal to it has a unit root. Okay, so here the test is what the data is. Alternative, it's either stationary or explosive. I'll explain what explosive in the course of this discussion. So ang pinaka-base lang natin, ito lang, no? Okay. X is a numeric vector or time series. Alternative indicates the alternative hypothesis and must be one of stationary, which is the default, or explosive. Okay. And then the lag, yung lag kung ano yung seasonality niya. For example, kung monthly, then K is equal to 12, no? Okay, so this is coming from. Okay. Now, before we test our data, ang maganda dito, guys, may may mga example siya. Okay, let's do this. Let's copy this. Control C. Okay, before we do our data itself. Okay, dito natin ilagay. Okay, I'm going to insert it here. We follow along na lang, guys, no? Insert. Okay. Now here we're generating random numbers, 1,000 of them. Okay, 1,000 random numbers. And then what's the mean here? What is the mean, guys? The mean is, anyone, guys? What's the default for this? Don't run this yet, guys. Would you know, guys? Again, guys, it's
500 po, sir.
no, not 500. Again, guys, pag always yung help function ni R, makakatulong yan, R norm. No? Yan. This is the function that we're using. Okay, so it generates a random numbers that follow the normal distribution. Okay, so ito yung default na syntax. N is the number of observations, you know. And then mean is 0, and then standard deviation is equal to 1. So if we don't put here mean, you want mean equal to 100, kailangan you have to put that. If you don't put anything, then it will assume, R will assume that the mean is equal to 0, and then the standard deviation is equal to 1. Okay? So may mga example din dito, ano? Yan, may mga example dito. Okay, in order for us to generate the same, did we discuss this last time, guys? How do we generate the same random numbers? You recall that? Or did I mention it in this class? Kasi pag ino natin to, guys, kapag if we run this, we will have different random numbers kasi random numbers nga to eh. No? But I want us to have the same random numbers. So what's the function that we're going to use? Anyone? Okay, di ko pa ba na-discuss? Kindly chat yes or no, guys? Not yet? Yes or no? Finstad, okay. So burn. So ano yung function na yung burn? Do you recall? Nakalimutan.
Nalimutan ko po, sir. So kasi
sige,
yun
sige.
yung first lesson ninyo eh.
Okay, sige. Okay, it's okay. Now, kasi guys, pag generate natin to, iba-iba yung numbers natin. Sample lang muna tayo ha. So let me just show you for the benefit of those who were either have forgotten or who were not under me. Okay. Dito ko lang ilalagay sa console ha. Okay, here. All right, so I'm going to generate these random numbers, R norm. 10 lang guys, 10. Okay, let's generate this. Run this in the console. Control Enter. Okay, what do you notice, guys? Do we have the same numbers? Yung rinan nyo to? Did you generate the same numbers?
Hindi po, sir.
No, magkakaiba tayo kasi random numbers yan eh. And if we get the average, mean, okay, gawa natin ng object muna to, no? Let's call this R1. Okay, R norm. Okay, so I'm generating, let's generate a 10 random numbers. This is normally distributed with mean equal to 0 and standard deviation is equal to 1. Yun ang default, ha? Control Enter. Okay, R1, I'll print R1. Okay, notice na iba na kagad guys, ano? Iba na kagad yung random numbers as compared to what I did a while ago. Okay, so if I get the mean of this, mean of R1, okay, mean of R1, so that's negative 0.32. Okay, medyo malayo guys, medyo malayo sa 0 kasi ang default nito 0 mean. And standard deviation SDR1, R1, okay, the object R1, okay, it's 0.83, quite far from from 1, okay. It's because guys, mali itong observations natin, sa 10 lang eh. Okay, but if we increase this, suppose R1, no? R1, or I'll call it R2. R2 alt minus, and then R norm. Okay, without printing guys, I'll generate let's say 1 million. And 1 million yan ha. So hindi ko muna ipiprint, no? Okay, control enter. Okay, so may R2 na tayo, no? May R2 na ako dito. Okay, here, R2. Large numeric, 1 million observations yan, guys. Okay, if I get the mean of R2, okay, so yan, di ba? Practically 0, no? Standard deviation of R2, practically 1. Okay? So medyo malayo guys yung yung una, yung mean equal to 0, hindi naman siya actually equal to 0, no? Negative 0.32, medyo malayo siya. It's because of the very small sample size. So mahihirapan talaga kung mababa yung sample size, no? Ito 1 million yung sample size, ano yung mean niya? Okay, practically 0, standard deviation 1, which is the default. Okay, so here guys, we generated different random numbers. So in order for us to generate the same, we're going to use the function set.seed. Yan ang gagamitin natin na function. Set.seed and then identify the same number. Kunyari 99. Okay, any number guys, any number. Can be 100, pero dapat pare-pareho tayo. Okay, kasi kung hindi tayo magkakapareho, then magkakaiba yung natin, yung random numbers natin. So this will make sure that the random numbers that's being generated are the same for all of us. Okay, sige. Set that seed tayo. Okay, sandali, pause muna ako kasi I might be talking too fast. Okay, I'll give you a few minutes, guys, to also experiment on this. Sorry about forgetting that you also need to experiment on this and do this. Sige, guys, I'll give you a few minutes. And then when you're done, guys, kindly chat. Pakasabing done. Okay, yeah. David, thank you. You're correct. Set that seed siya. When you're done, guys, doing this, experimenting on that, guys, paki-chat na yes. No? Thank you, Bern. How about the rest, guys? Sana, I hope you're following, guys. Huh? Of course, you can you can run the code here sa script window natin. Pwede rin dito sa console. So let's wait for the others to be able to follow. When you're done, kindly chat, please. Yes, so that we can, I know when to continue. Okay, how about the rest, guys? Only two have chatted. Okay, how about the others? Are the others following too? May questions ba yung iba na I'm sorry guys, I was writing the codes very fast. No? So, kamusta guys yung walo? Hindi. Eight of you have not chatted. Okay, so yeah, okay, good. Good. Thank you so much. Guys, if I'm moving very fast, remind me na lang ha. Sorry, I'm very sorry about this. Minsan kasi I tend to forget that you will have to also write the code and see for yourself. Okay, so I'm just waiting for 3 more, just in case may mga questions pa. Okay, so thank you guys for chatting. Guys, again guys, reminder, hindi marathon tong ginagawa natin to, no? Okay, I would rather that we go yung pace na tama sa inyo. Okay, and do not be ashamed to call me out, guys, if I'm moving so fast. Okay, so what are we doing now, guys? We are trying to illustrate the difference between a stationary data series and a non-stationary. We have an example of the non-stationary in the AP, in the object that we were looking at a while ago. Now let's generate an object, okay, called X. Okay, di ba kanina yung AP natin ito, no? Ito yung AP natin. Okay? And plinat natin siya, no? Ito yung AP function natin. Okay? Now we will create another object, random numbers to, and we'll call it X. Saan na siya? Okay, here. Now, in order for us to have the same figures, okay, we will set that seed to 99, and then, okay, sige, i-run muna natin to, guys. Oops. I-run muna natin tong set that seed at saka yung X natin. All right, so what happened now? We now have an object called X. May X na tayo na object, no? And it consists of numerical to 1,000 observations all in all. So what happens? Let's plot, guys, yung X natin. Okay, take a look at X, guys. Yeah. That is what we mean by stationary data. Stationary siya. Walang trend, no? Walang trend, walang seasonality, and the mean is constant. Take note, guys, ang mean ito 0. That's what the R norm does. It gives us, depende kung ano yung mean na sinabi natin. Hindi tayo nagsabi na mean, kaya ano to, yung default na mean is equal to 0. And standard deviation, guys, is constant. Okay? So this is an example of a stationary data. And when the data is stationary, then we can make use of Box-Jenkins ARIMA model. Okay, yun. That's the point, guys, of understanding, of knowing why the data has to be stationary. Kasi we cannot use the Box-Jenkins approach, yung ARIMA model, if it's not stationary. Okay, let's test, guys, using the ADF test, the augmented Dickey-Fuller test. I-test natin kung ano to, kung stationary nga siya. Control Enter. All right. So what do we have here? Okay. Augmented Dickey-Fuller test. Okay. Ang data natin X. Okay, this is the Dickey-Fuller stat. Okay, p-value is equal to 0.01. Okay. So what's the null hypothesis here? The null hypothesis is, ilagay natin dito, no? Ang null hypothesis natin dito, the data has a unit root. Okay? Pag may unit root, guys, anong ibig sabihin yan? Non-stationary yung data. Okay. So based on this statistical test, what's our conclusion? P-value is 0.01. It's less than 0.05. So therefore, guys, we reject the null hypothesis that the data, X data, has a unit root or non-stationary. Ang alternative hypothesis siya na stationary yung data natin. Okay? So ibalik ko yung plot, guys, plot ng X. So dito kitang-kita guys na, ayan, no? Obvious na stationary yung data natin. But we don't just rely on the visuals. Okay, we don't just rely on this. We do a statistical test. Okay, so remember guys, when we are testing whether a data is stationary or not stationary, when the data has a unit truth or non-stationary, then we make use of the augmented Dickey-Fuller test, ADF test. And the null hypothesis is that the data has a unit truth or it's non-stationary. So we would want to reject that null hypothesis para stationary yung data natin. And true enough guys, ito as suspected, kitang-kita naman visually. Okay, the data has no trend. Okay, wala, mean is constant and variance is constant. So this is stationary. Okay, pause ako for a while. Any questions guys? Clear ba so far?
Sir, pwede pa
Yes.
clarify lang, sir. Paano mo nalaman na walang unit root?
Okay, so two ways, no? Visually, no? Ang ibig sabihin ng no unit root, ibig sabihin ng stationary, ha, guys, ha? Okay, clarify natin. Pag sinabing the data has a unit root, aka also known as non-stationary siya. Okay? When we plotted X, kita nyo naman, no? Random numbers lang to eh. We use the R norm function, 1,000 observations, and then pare-pareho tayo niyan, guys. Eh, dapat pare-pareho din tayo ng plot, ha? Kasi yung values natin pare-pareho, no? Okay, test lang natin, ha, just to satisfy our curiosity. Kuha natin yung head ni X, no? And then let's just generate the first 5 values. The head function of R will give us the first, depende guys, kung hindi natin lalagyan ng number, the default is it will give us the first 6 observations. Okay. Kung hindi natin lalagyan ng number, no? Pag lagyan natin, kunyari 10, then it will give us the first 10 observations. Run nga natin guys. Oh, pare-pareho ba tayo? 0.213, 0.4796. The same, paki-chat nga guys. Paki-chat in the chat box if we have the same figures. Okay, I'm waiting for the others, guys. Okay. Good, good. Thank you. Thank you so much. And just to be sure, guys, tingnan natin yung tail, yung dulo, no? Tail of X, just the last 3. So, ang default din na tail, guys, 6 din yan. Kaso, dito, ni-specify natin na 3. So, it will just give us the last 3 values of our X object. So, it should be the same, guys. Okay? It's just to satisfy our question whether we were able to generate the same data set. Yan, tama. Parehong-pareho. Thank you, Bern. Exactly the same. Okay, thank you. Okay, very good. Okay. Now, balik ako sa question kanina. No? Paano natin nalaman kung may unit root siya? Okay. Ang ibig sabihin, guys, ng may unit root, if it has a unit root, ibig sabihin nun, non-stationary siya. No? Okay, ano ibig sabihin ng non-stationary? May trend. Plot ko ulit to, no? And then yung AP na lang. Balik tayo dito. This one, guys, is non-stationary to. Okay, ibig sabihin, walang unit root to. No? Non-stationary. Okay. It has, okay, sandali ha. Okay, this is non-stationary. Ibig sabihin, sorry, I stand corrected. Non-stationary siya, ibig sabihin, it has a unit root. Okay, we'll explain later on, guys, yung technicalities. Ano ibig sabihin ng unit root. Okay, but now, guys, suffice it to say that for our appreciation, pag sinabi natin the series has a unit root, ibig sabihin nun, non-stationary siya. Okay, kailan non-stationary, guys? May trend. You know? See? it's going up, and may seasonality. So those two components. May trend, may seasonality. Pwede rin may trend lang, walang seasonality, non-stationary pa rin yun. Okay? Pwedeng walang ano siya, walang trend pero may seasonality, then that's still is a non-stationary data. Okay? So whether may trend lang siya or may seasonality lang siya, okay, that's still it's still a non-stationary data or it has a unit root. On the other hand, okay, sabi natin ito yung data natin na to, si X, which is just random numbers, ito. Saan na si X natin? Okay, saan na siya? It's here. Okay. Plot natin si X. Okay. Yan. May trend ba siya? Wala. May seasonality ba? Wala. So ito guys, stationary to. And sabi natin, pag stationary yung data, then that means that we will be able to now use Box-Jenkins in order to model this. Okay? Siguro titingnan natin yung model nito, but we won't be able to get that far today. Siguro next meeting, i-model naman natin to. What we're going to do now is to look at the AP data natin. No? Okay, so alam natin guys, si AP has a unit root. The data has a unit root. Or the time series is non-stationary, no? Non-stationary time series natin. So we're going to test now, statistically guys, kasi kanina visual lang eh. Pero obviously, ang makukuha natin dito guys, ang result, let's run this. Okay, so this is coming from the package T-series, and then the function is adf.test, AP. Then alternative natin, stationary, K is equal to 12 is the frequency. No? Run natin to. There. So this is the Dickey Fuller statistics. Then the p-value is 0.7807, which is greater than 0.05. Then our inference is that we failed to reject the null hypothesis. So this is indicating that our data, AP, has a unit root or it is non-stationary. Okay. Clear so far, guys? Okay, now last meeting, we also did this, no? Sabi natin, before, okay, importante na pinaplot natin yung ACF at saka PACF. What's ACF? Autocorrelation function. And then also the PACF, partial autocorrelation function. Okay. Now, if we plot this, this will also indicate kung ano siya, kung stationary siya o hindi, no? So let's do this. Autoplot using the autocorrelation function, yung data natin, yung AP, log, titingnan natin 30 months. Ibig sabihin, titingnan niya yung correlation up to 30 months. Month 1 up to month 30 hanggang ganun kalayo. Okay, and then we will add this one, label, ang title natin, ACF of air passengers. Okay, of course, we could have just placed here yung main, no? Okay, sige, run natin to, guys. Okay. Okay, so this is the ACF, guys, autocorrelation function. Now, pag ganito yung autocorrelation function, guys, it's indicative that this is non-stationary. Okay? Non-stationary ito kasi yung ACF usually, kapag ARIMA model, may spike lang sa una tapos wala na. Hindi na significant itong mga to. Okay, it tells us, guys, that this one, may positive correlationship between the first value and then the next value. Okay, also the next value and the next value are statistically significant. Kasi pag may autocorrelation, guys, yung mga values na yan, okay, ibig sabihin si time 2 is autocorrelated to correlated to time 3, time 3 is correlated to time 4, time 4 is correlated to time 5, etc. Or time 1 is correlated to time 20, time 1 is correlated to time 30, then that's indicative, guys, na nag-a-affect yung mga data points natin to each other, and it's indicative that it will be non-stationary. Kasi dapat, guys, pag stationary, random yan eh. Okay? One data point does not affect yung succeeding or yung previous na data point natin. Ito, kita natin, no? Malakas yung autocorrelation nila. Correlated yung mga data points natin over time. Okay? So this is an indicative, guys, that this is a non-stationary data. Ganun din, guys, yung partial autocorrelation function. Plot natin to. Okay, so let's just wait. Okay, so that's one use, guys, of plotting yung ACF natin at saka PACF. Okay, I would, guys, that you be familiar of this, no? Kasi dati talagang gamit na gamit yung ACF at saka PACF. Ngayon kasi, now, meron ng may mga let's say may mga tools na para so that we won't need so much yung ACF and PACF. Okay. So, saan ba ginagamit yung PACF? Para ma-establish natin kung may relationship between the values. And a second use of that is it identifies whether you're going to use an AR model, an MA model, an ARMA model, or an ARIMA model for your data series. Okay? So, okay, we'll have, maybe next meeting, I'll show you some examples, no, of ACF and PACF. And then try to determine anong model kaya gagamitin dito, no? AR process or MA process, etc. Okay. So okay, ito na yung modeling, guys, ano? Okay, before we go here, okay, did we reach up to this point last week, guys? Ito. Umabot ba tayo dito sa pag-generate natin ng itong ginamit natin yung auto.arima? Kindly, okay, ito, guys, itong auto.arima function. Did we reach up to this point last meeting? Sorry, hindi ko nalagyan, no? That's why I have to put kung saan tayo tumigil. Paki-chat, please, kung if you recall us discussing auto.arima. Hello, guys. Okay, no, thank you, Bern. Okay, so siguro all of you can attest naman na we get to that point, no? Okay, so okay. Before, guys, pag minomodel namin itong mga time series na to, we will have to do transformation. Kasi we cannot use the Box-Jenkins approach in order to model AP. Why? Bakit hindi natin, guys, magamit? Kasi hindi siya stationary. Okay, ito, guys, ano na to automatic na to ngayon no? Dati wala naman kami ginagamit na R. Ngayon, guys, ang dali na pwede ka na mag-auto.arima tapos siya na bahala, no? So what we're going to do is mag-manual muna tayo, no? Okay? We know that AP, guys, is not stationary. So what are the two methods by which we can transform your data and make it stationary? Ano sinabi ko kanina, guys? There are two ways. What are they? Anyone, please? Backtrack kayo dun sa notes natin kanina. Ano yung dalawang methods na pwede natin gamitin in order to transform a data into a stationary data series? Transformation burn. Paano natin ita-transform? Okay, there are two ways. We have the log transform, di ba? And the differencing. Ito, guys, ito. Okay, copying ko nga to. We can do the log transformation and also the differencing, or even the combination of both, no? Sige, isa-isahin natin ito muna, no? So when do we use the log transformation? We use the log transformation in order to address yung unequal variance. Okay. yung AP natin guys, unequal yung variance natin. Tingnan nyo. Diba? Over time, nag-i-increase yung deviations natin. So that's unequal variance. So let's create an object. Let's call it a log. No? AP log. Gawin natin AP log. Okay, here, AP underscore log. Okay. So we're creating an object called AP log, alt minus, and it's the log of your AP. Okay. Tingnan natin guys ha. Log ng AP. Okay, so what R will do is it's going to get AP and get the logarithm of this. Kukunin niya yung log niyan. Okay, kunin natin yung log nito. Okay, and then let's have it printed AP underscore log. Okay. Sige, run natin guys, run. Oops, ano nangyari? Ay, sorry. Underscore dapat to. Underscore, okay. Run. There. Okay, i-view natin para makita natin dito. View AP underscore log. Yung log guys are, for those of you who don't know, ang base nito E. In other words, this is ln actually, natural logarithm. It's not base 10. Sige, run ulit natin guys. Okay, para meron tayong, yan. Tingnan nyo guys, what happened? What happened to your data? Yung AP kasi natin, tingnan natin AP ha, 112, 118, towards the end, naging ano na, no? 400, 500, 600. Okay? So what happened to your AP logarithm? Notice guys, 4.7 sa dulo. Okay. 4 to 6 lang, no? 4 to 6 yung range natin. So that's why we said that taking the log of your data will address the variation. Kasi itong AP, ang variation natin from 100 ba? From 100 naging up to 600, no? May 600 eh. Yan, may 600. So malaki yung variation nila. But when we get the log of that, guys, when we get the log of the data, notice, na-scale siya. So bumaba yung variation. And if we plot, i-plot natin guys, tingnan natin ha. I-plot natin si AP log. Log, okay. Plot AP underscore, oops. AP underscore, oops. AP underscore log. Let's plot this. Okay. What do you notice, guys? What happened? Na-address ba yung variation? Na-address ba? Diba medyo na-address, no? Yung difference between the peaks and the troughs, hindi na siya yung parang kanina na masyadong lumalaki over time. Meron pa rin, pero it's a lot now, it's a lot minimized now. Okay, so this was able to address yung variation niya. Okay? Okay, pause muna ako guys. Sige. Do this first. Okay, I might be going too fast again. I'll give you a few minutes to do that. Yeah, thank you, David. You're correct. No, remove the unequal variance. That's what doing the log does. Kasi kung i-compare natin, sorry compare muna natin. Tingnan nyo guys, tingnan yung variance, di ba? Nagfa-fan out siya, lumalaki siya over time. Eh, dito naman sa log ng AP, ano nangyari? Di ba medyo uniform na siya? Okay? Na-address na yung unequal variance natin. Okay, sige, I'll give you a few minutes, a few seconds guys to plot that, and on your own, sige, follow. When you're done, kindly chat guys kung okay na, no? Chat na lang na okay or done, so that I know when to continue. It's important guys that you follow along na gawin nyo Kasi iba yung talaga nag-hands-on din kayo. Iba yung sinusundan nyo yung natin. Thank you, David. Okay, let's give a few more minutes to your classmates. Kindly chat, guys, if you have any questions, if you need clarifications in some of our codes. Thank you, Nick. Let's wait for the others. Okay, Sophia, thank you. Okay, waiting for the others, guys. Yeah, thank you, John. Okay, good. Okay na? Okay, good. Okay, thank you so much, guys, for your feedback. All right, so question. Is this stationary? Okay, just by viewing it, guys. Is this stationary? Si AP log natin. Take a look at the picture, guys. Okay. Is that stationary, guys? Answer? Stationary ba to? Okay, Bern, bakit siya stationary? Remember, Bern, ang pag stationary dapat walang trend, constant yung variance, no? Dalawang conditions yung dapat ma-meet. Ito mukhang constant yung variance kasi across this, mukha namang wala na masyadong fluctuations dun sa no? Nagba-vacillate na lang siya across this constant frame, no? Pero it still has a trend. Diba? May trend to. So, back to my question, guys. Is this a stationary data series? Yung AP log natin. Kindly chat, please. Chat? No, thank you. No, yeah, correct. Hindi siya stationary. So hindi pa natin 'to magagamitan ng na-remedy yung yung non-constancy invariance, pero yung trend, yung constancy in mean, hindi niya nagawa, no? Okay, and let's do a ADF test natin. ADF.test. Okay. So that's our AP log. Okay. Anong sinasabi na augmented decay folder? Okay. What does this tell us? Okay, wait So, i-full natin yung yung isama natin to. Kasi may seasonality to, no? So let's complete this. AP log alternative. Okay. Okay, yan. Ito na yung tama, no? Kasi hindi natin sinama kanina yung frequency, yung monthly monthly data natin. So, again, our null hypothesis here is that there is a unit truth or the series is wait. Bigla akong nalito. Okay, the series has a unit truth or the series is non-stationary. P-value natin, guys, our P-value is that 0.77, okay, which is greater than 0.05. Therefore, we fail to reject the null hypothesis that the series is non-stationary. Okay, hindi natin ma-reject yung series na non-stationary. So tama siya, guys. Tama, non-stationary siya. No? Non-stationary pa rin data natin. Okay, now let's go here. Ang gawin naman natin ngayon, guys, di ba kasi may trend? Why don't we create an object called AP_diff? Ito yung ginagawa, guys, ng in order to address yung trend, no? Or non-constant yung mean. Okay, what we do is we get the difference. Ano yung difference, guys? What's the difference? Okay, tingnan natin ha. Okay, question diff. What does the difference function do? Okay. So diff, tingnan natin dito, time series. Okay. So we have diff, and then there are several parameters pa. Okay, may example ba tayo dito? Microsoft, okay, diff. Okay. Anyway, ang diff, guys, ang diff will get the differences yung log ng data natin, no? For example, AP. So yung una natin here, 112, then 118. Ang gagawin, guys, pag dinidifference natin, mina-minus natin. So it will become 118 minus 112. Okay, 132 minus 118. Okay, that's log 1, no? Log 1. Kung log 2, 132 minus 112. And then 129 minus 118. So when we say differencing, we're getting the difference between consecutive, kung log 1, no? Consecutive data points. So let's do that. Okay, difference ni AP, okay, then log is equal to 1. Log 1 lang, guys. Ibig sabihin, kukunin ni R, magge-generate siya ng panibagong dataset called AP diff, and then ang gagawin niya, kukunin yung differences among the data points. Okay, so let's see. I-view na rin natin para view AP diff. Para makita na natin. Let's run this. Run. Okay. All right. Tingnan nyo, guys, no? 6, 14, okay, negative 3. Paano nakuha itong 6, guys? Then 14, then negative 3. Diba ito yon, diba? 118 minus 112. That's 6. 132 minus 118. That's 14. 129 minus 132. That's 3. Okay? So we generate the difference data by getting the differences between two data. Okay, so let's just try another one. Paano kung, okay, so malapit na mag-time. So here, AP underscore diff, let me say log 2. Okay, log 2. And then this one, AP, okay, diff, difference ng AP, comma, log is equal to 2. Okay, ito, guys, 2 yung log, ano? Tapos i-view na natin para kita natin. View, then AP, log, AP, so diff, log 2. Let's run this. Okay. Sige, ano nangyari, guys? Paano nakuha yung 20 dito? 20. Okay, kasi kung titingnan natin to, okay, tingnan natin si AP dapat. So 132 minus 112. Log natin 2. So 2 observations, no? And then 129, 118. So that's 20 and then 11. Let's check. Yan, 20 and then 11. Okay? So that's how we get the difference data, no? When we say differencing, we're getting the difference between data points depende dun sa log. Pwedeng log 1, pwedeng log 2, etc. No? Okay, may nag-chat ba? Okay. All right. Sige. So, let's go back here to our code. Okay. Tingnan natin guys, ano nangyari kung gamitin natin si log 1. No? Okay. So, for log 1, dito ko na ilalagay. Insert. Okay, let's plot. Plot AP underscore difference. Yan lang naman, di ba? Plot AP difference. Sige. Ano nangyari dito sa difference dataset natin? Okay, Control Enter. Okay, what happened guys? Ano na address niya? Ano na address? Anyone, please? What was addressed? Can unmute yourself, guys, para ano na lang, verbal na lang. Hello? Guys, ano na address natin? Ano na wala? Any brave soul, guys? What do you notice, guys? Naging constant ba yung mean? Yes, guys. Although dito, guys, matataas yung variation niya. Pero pag kinuha mo yung average yan, constant pa rin yan. The mean is not changing. Sa ano na to, sa period na to, ito yung average eh. Sa period na to, guys, although tumataas yung variation niya, yung mean dito pa rin. No? Okay, so what was addressed, guys, when we difference? When we difference, what's addressed is the trend. Okay? Kanina, hindi constant yung mean. Ngayon, constant na. Pero, ano yung problema natin? Yeah, thank you, Sophia. You're correct. It's the trend, guys. It's the non-constancy of the mean. Ngayon, constant na yung mean. Question, is this, guys, is this, since wala naman siyang check natin yung, yung ADF test natin. Okay, AP, diff. Okay. Okay, since may seasonality siya, okay, kailangan natin ilagay pa rin yung ano dito, no? Okay, so let me copy the alternative and then the k is equal to 12. It will give us a wrong answer, guys, kung hindi natin sisama yung seasonality. Okay, here. There. Okay, let's run this. Okay, ano nangyari, guys? What are we told? This data, yung AP difference, is still non-stationary. We were not able to reject the null hypothesis, no? That there's a unit root. May unit root pa rin siya. Ibig sabihin, pa rin siya, non-stationary. And that can be seen, guys, kasi may tayo eh, may yung variance hindi constant. Okay? So what's usually done, guys, lastly, magta-time na, lagyan natin dito. So to address this, ang ginagawa, so let's create an object AP and then log and then difference. Okay. So kino-combine yun. Kino-combine siya. So kinukuha natin yung difference ng log ng AP. AP. And then anong difference natin? Log is equal to 1 lang. Okay. So what's happening here, guys? We're getting the difference, we're getting the log first of AP in order to address the variance. And then we get the difference in order to address the trend. Kasi kanina nung nag-log AP lang tayo, nawala yung variance, di ba? Naging constant na yung variance, pero may trend pa rin. Okay? So after we do get the log, guys, ang gagawin natin, kukunin natin difference in order to address the non-constancy of the mean. Okay? So sige, i-ano natin to, i-view natin. View AP underscore log diff, and then i-plot natin. Okay? Sabay-sabay na. Plot. Okay? AP underscore log diff. Alright. Sige, run ko to, guys. Okay. So we now have an object called AP log diff. Yan na, no? We get the log and then the difference. And then i-view natin siya. View. Okay, take note guys, ano na lang ha? 143 entries. Ang original niyan, 144, di ba? Nabawasan ng isa kasi nag-difference tayo. Ganun din guys dito sa difference dito, 143 na lang. Okay, sa log, 144. Kasi kinuha mo naman yung log eh. Kinuha mo lang yung log, hindi ka naman nag-difference. Okay, so, alright. Now let's plot. Tingnan natin guys kung ano nangyari dun sa log difference na na data natin. Okay, tingnan nyo. There. Yun. Constant na yung variance, constant na yung mean, wala nang trend. Okay? And if we check guys, kunin natin to, copy na lang natin to. ADF test natin, Control C. Okay. Control V. Okay, so log diff natin to. Log diff. Yan. Okay, let's check guys kung stationary na ba itong data na to. I'm going to run the augmented Decomposer test of our AP log difference data. Okay, alternative stationary and K is equal to 12 should be in my seasonality siya. What happened guys? There. Okay, so at although guys 0.06, no? Okay, at 0.10, at 10%, we're able to reject. Okay, we're able to reject the null hypothesis that our data has a unit truth. No? So, pwede natin, we can say that at 10% confidence interval, that our data, our AP log diff data is stationary. Okay, and since it's stationary at the 10% confidence interval, we can now model this. Okay, so next meeting guys, ang gagawin natin, mag-model na tayo. I-model na natin guys yung model natin si AP natin, i-model si titingnan natin kung how about if we model AP dot log and AP underscore difference log and AP difference, no? We're going to compare all of them. So next meeting guys, tatapusin natin to. Okay? We're going to finish this and then we're going to use another file, extend natin si time series. So makakapagsimula tayo ng Garch, Garch modeling at saka yung mga iba VAC, bar, and Granger causality, etc. Okay? Alright, it's already time guys. Did you learn something today? May natutunan ba kahit paano guys? Paki-feedback naman Okay lang kung sabihin yung wala, no?
Yes, sir.
Parang galit yung yes sir. Totoo ba yan, guys?
Oh, no po, sir. Yeah. Yes, sir.
Joke lang. Okay, so so far guys, okay naman tayo. Okay naman yung pace natin.
Yes, sir.